Hi everyone. In this video we will finish looking at exponent rules and then we'll go over a few examples of how to simplify expressions that have exponents in them. So to start off, we're looking at some exponent rules. I want to finish up our exponent rules by looking at a few other cases. The first one is looking at parentheses. So what role parentheses play in exponents. So I want to look at the difference between these two expressions. First we have 2 times x to the third power, and we also have in parentheses 2 times x, that entire expression, to the third power. So these two expressions are very different, and it's important that we know the difference between these and why the parentheses are really important in this case. For the first one, letter A, 2 times x to the third power, if we wanted to write this in expanded form, we would write it as 2 times, so first I could break it up like this, 2 times x to the third, and then we can break up the x's, 2 times x times x times x. So that is expanded form for 2 times x to the third power. Here we have 2x, and that entire expression to the third power. So in expanded form, it would look like 2x times 2x times 2x. In other words, because we're multiplying all of these, we can move them around, order of operations. We get 2 times 2 times 2 times x times x times x. Which, if we wanted to simplify, we could write as 2 to the third times x to the third. So notice in this case, the importance of the parentheses means that the 3, the exponent for the 3, is applying to everything inside of the parentheses. So the 2 and the x are both being raised to the third power, whereas in our first example, only the x is being raised to the third power. So one way to think about it is you distribute the exponent to the 2 and the x. Distribute isn't really the right word, though. It's not the distributive property. We are just applying the exponent. So both of them are being raised to the third power. So notice we have 2x to the third power. We ended up with 2 to the third power times x to the third power. So the parentheses are really important. We can also do this with division. If we had 2 divided by x to the fourth power, for example, we could rewrite that as 2 to the fourth power divided by x to the fourth power. So we can apply the exponent to both the 2 and the x, numerator and denominator, because we're multiplying the numerator 4 times and we're multiplying the denominator 4 times if we write it in expanded form. I suggest using expanded form if you're ever confused or unsure about what to do when we're simplifying expressions like these. Okay, next I want to take a look at a few examples of solving or simplifying expressions with exponents. All right, so here we have a few example problems where we can use what we know about exponent rules to simplify these into a simpler expression. For example, looking at letter A, we have y to the fifth times y squared. For all of these, you can always write them out in expanded form. Sometimes it just takes longer, so that's why I recommend looking at and using the exponent rules. So here, if you wanted to, you could write it out. We have 5y's, and we're multiplying the 5y's by 2y's, so we end up with 7y's total. But we could also use our exponent rules. If we're multiplying and we have the same base, that means that we can add the exponents. So 5 plus 2. Which gives us y to the 7th. Okay, next up we have letter B. Here we have the same base and we're dividing, so we can either use our exponent rule or we can also write it in expanded form. So expanded form, we have w times w times w times w times w. We have 5 w's divided by 2 w's, and 2 of these cancel out. In other words, simplify to 1. W divided by w equals 1. We have 3 w's left over, or w to the third power. Again, we can use our exponent rule, same base, so we can subtract the exponents. This is also equal to w to the 5 minus 2 power, which gives us w to the third power. So our exponent rule is a shortcut in this case. Next up, we have letter C. Here we have a few more letters and numbers. We have 24 times h times g squared, all divided by 3 times h times g to the 9th power. What we can do here is we can split this up and match up the variables and the numbers. So we can write this as 24 divided by 3 times h divided by h times g squared divided by g to the ninth. So just matching up the numbers and the different variables. Let's start on the left. 24 divided by 3. We put that into our calculator. That gives us 8. H divided by h gives us 1. And then we have g squared divided by g to the ninth. And again, we can use our exponent rules here. G squared divided by g to the ninth gives us g to the 2 minus 9 power, which is g to the negative 7 power. And here we have a negative exponent, which means that we're taking the reciprocal. In other words, we're taking 1 over g, because we had g over 1 before. G over 1 to the negative 7th is equal to 1 over g to the 7th. And again, we can apply the exponent to both the 1 in the top, 1 to the 7th, and the g in the bottom, over g to the 7th. So 1 over g to the 7th. So this last term that we're multiplying is 1 over g to the 7th. All right, so finally 8 times 1 is 8. And then if we're multiplying a number by a fraction, here we can take this is the same as 8 over 1. So we can multiply 8 times 1 8, and then 1 times g to the third is g to the, g to the 7th. I wrote that wrong. That should be g to the 7th. So our final answer here is 8 divided by g to the 7th. And we start off by splitting up our fraction and matching up the different variables and the numbers. All right, finally we have letter D. In this one we have 2 times m to the third divided by n to the 10th power, all divided by, all raised to the 4th power. So you could start by writing this out in expanded form, so writing out 2 times m to the third times divided by n to the 10th, and doing that 4 times. It would be easier though to use our exponent rules to help us out here. So first we have a fraction. We have 2 times m to the third on top, and we have n to the 10th on the bottom. And this fraction is being raised to a power of 4. So as we saw earlier, if we have a fraction, if we're multiplying or dividing, and it's being raised to a power, we can apply the exponent to both the numerator and the denominator. So we're going to apply the 4 to the numerator and also the denominator. So 2 times m to the third to the 4th power divided by n to the 10th to the 4th power. Okay, first let's take a look at our numerator. So here we have 2 times m to the third to the 4th. As we saw earlier in this video, if we have parentheses, that means the 4 is applying to both the 2 and to the m to the third power. So we need to make sure that we raise the 2 and the variable m to the third power, raise both of those to the 4th power. So 2 to the 4th power times m to the third power to the 4th power. Okay, 2 to the 4th power gives us 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 times, and if we have a power to a power, one of our exponent rules is we multiply the powers. So m to the 3 times 4 power. So 16 times m to the 12th power. And this is our numerator. For our denominator, so here I'm just doing my work off to the side, and then I'll move them back up to our equation once we're done. We have n to the 10th power to the 4th power. So again, we have a power to a power, so we can multiply the exponents. N to the 10 times 4 power, or n to the 40th power. Okay, so we have our numerator, we have our denominator, so we can return to our fraction, and then replace the numerator with our simplified numerator, 16 times m to the 12th, divided by our simplified denominator, n to the 40th. And this is our final answer for this expression. So in these examples, we used all of our exponent rules, including the final ones we learned today about grouping, to help us simplify our numbers with exponents into a simpler expression. So always make sure you match up the variables, and especially if they're grouped together, you apply the exponent to both numbers being multiplied or divided.